we are picking up in lesson 3.3 on example 5D in this class, it sounds like, going by what you guys are telling me. So we were solving these log equations here. And as we were solving these log equations, how do we get it out of log form? Remind me from yesterday?
Left, right, middle.
Left, right, middle. Okay, we learned this back in Algebra 2. And in this class, you guys were all with me last year. So left, right, middle. So the left mean the x raised to the right, which is the 3, which equals the middle, which is 64.
Cube root.
Okay, now this one looks a little bit different than all the others we've solved, doesn't it? But you can go back to the old standby of if it's x cubed, we're going to take the cube root.
Wait, I forget how to type it in my calculator.
So on these calculators, the cube root, it's up in one of the alpha menus or it's in the math menu. If you just hit the math button, it's right there as one of those options. Okay. The other option, and I'm not against you taking, whoops, didn't mean the cube root, but you could cube root it. The other thing, what do we know about 64? 64 is what to the third power? 4. So the other option, along the lines of how we've been rewriting, well, like here, we had 3 to the x equals 1 over 9. We rewrote to be 3 to the x equals 3 to the negative 2. Along the same lines, we can write x to the third equals 4 to the third. And if the exponents are the same, then we know the bases are the same. And so we know x is 4. And again, I'm not opposed to if you just did the cube root. Makes total sense. Okay. On the back side, my plan is to do example 6 and 7. We are not doing the graph. We're not doing example 8. And I believe I've pulled the homework problems that relate to that. So if I didn't, well, let me know and I'll get it fixed. So the back side talks about natural logarithms. On the front side, yesterday we learned about common logarithms. And what base are common logs?
10.
Base 10, right? And when you see the log button on your calculator, what base does that work in? Base 10. Now, the other type of log that we often talk about are natural logarithms. And you have a button for natural logarithms. Natural logarithms is your LN button. And I don't know if you guys can read this or not, but natural logarithms are base E. So that is an E there. I don't know that you will ever see log base E of x written, because if it's base E, we just write it as natural log. Okay, and that means natural log, you are assuming base E. Now, these first 3 say to evaluate without a calculator, so don't use your LN button. These are using our properties that we learned yesterday, and we used our properties on the front side. So what do you know about natural log of square root of E?
It's natural log e to the 1/2 power.
Okay, so first of all, the square root of E can be rewritten as E to the 1/2. So natural log of E to the 1/2. What is that equivalent to?
What?
What?
1/2.
Why?
Y is 1/2.
Okay, so 1/2 is what I'm looking for. What base is natural log?
E.
E. And so if this is the invisible base E, one of our properties says that when this base matches with the inside base, what is my log equal to? It's equal to the exponent. So natural log, log of when these bases match, it's equal to the exponent. And so this is equal to 1/2. Now, if you did the natural log of the square root of E on your calculator, guess what you'd get? 1/2. But we're practicing how do we use those properties. Okay?
Is that a little tiny 0?
That is a little tiny e that I then underlined. Because natural log is base E. In other words, we don't have to write it there, but there is a base E. And so trying to point out that the E's match. And because the E's match, it's equal to whatever the exponent is. Okay? What about B? Natural log of E to the 5th.
5.
5, because What is the base of natural log again?
E.
E. And what do you notice? The base matches the inside, and so it's equal to the exponent, which is 5. Okay. Another rule yesterday. E raised to the power of the natural log of 4.
I mean, yes.
Yeah, 4. And here's the deal. If I write this bigger, this is E raised to the natural log of 4, but what base is that? E. And if this E matches with this, in other words, if this base matches with the base of the log, our answer is equal to whatever's inside the log, which is the 4. Okay? Example 7, your favorites. Use the calculator. On this one, we're going to use the LN button as opposed to the log button. And so, and the LN button is right below the log button, right? So, type it in. And when you do natural log of 23.5, you get what to 3 decimal places? Approximately 3.157. So notice a log of a number bigger than 1 is positive. What can you predict about this next one? It's the log of a number less than 1. It's going to be negative. So what is the natural log of 0.48?
Negative 0.7.
0.724?
3.4.
0.734. Yes?
Yes.
This is where it's just helpful if I just look at my notes. So if I mishear you, I know what I heard, but. And I would encourage you to try C in your brain without your calculator.
Negative.
Natural log of a negative?
Undefined.
You can't do it. Undefined. Your calculator is going to say it's a non-real answer, right?
Yeah.
It's going to say error, non-real answer. It's going to say error of some sort. But you can't take the log or natural log of a negative value. Logs do not exist for negative values. And so the answer I put yesterday was undefined.
Would no solution also be equivalent?
Kind of, not preferred though. It's the idea that the log is not defined for negatives is the more the idea.
So there could be a solution, we just can't find it.
I mean, technically there's an imaginary solution. So, okay, I'm not doing example 8. Your homework goes with this. So your homework that goes with this assignment, and I would encourage you to write it down. 275, 1 through 36. I would normally say that's due tomorrow, but since I'm not here tomorrow, it will be due on Monday. Okay? I was finishing yesterday's lesson. Addie has this look like.
I was like,
This was me finishing yesterday's lesson. So finishing what you and Doug missed.
I
Okay.
was trying to figure out today was Wednesday. I was like, no. Yeah.